live yet. Hello everyone. Welcome to the stream. My voice is recovering from the weekend, which was extremely wasted. A lot of loud discussions because it's always loud everywhere. Hey Rohan, hey Peter, hey Dutch, hello Fruchti, hey Hannes. Yeah, long story short, here, my hair was so greasy, I needed to fix that for the stream. So you are not the only one who sometimes, yeah. Here we go. This is the nice PCB. It doesn't work. It just heats up. Hey Johnny, hey the Shipu. Spaces, no, it's tabs. I can tell you it's only tabs. Indentation only with tabs. Everything what happens after that, I don't care. So, what happened to this matrix? Okay, I sorted this one. Took me in more than an hour, I think. I don't know, maybe an hour with paste and stuff like that. And what I noticed is this is 0.4 millimeter pin pitch, so there were just bridges everywhere, and I used basically some like multi-strand wire as wick to get rid of the excess solder paste, and with a lot of flux the bridges were cleared. I plugged it in YOLO style into the mini PC and it just heated up. It was like 70 degrees, I think was the chip, and the LDO got even hotter. So I don't know what was happening there. Then I removed the 0 ohms cap. We can check this circuit. Here we go. I changed it a little bit since then, but there is this. Yes, what? Pat Deegan shown you a pic from Hackaday? What? Where? What? Oh, main, a resistor, sorry. 0 ohms resistor. So here it is. It splits the VCC 1.8. Oh, we have a new sub. Thank you, Sonic, and welcome. So we have this 0 ohm resistor and VCC 1.8. Well, maybe we have the data sheet. Yes, I was at Hackaday. That's what I said. That's why my voice is still sore. It was completely gone on Monday, and it was wild because like the whole traveling and accommodation stuff went completely wrong. I can tell you that. But in the end, everything went well. So everything went better than expected, and I had a ton of nice discussions about everything with the people on Hackaday. Didn't show anything except I took a few things that I showed around, like my matrices, like the magnet matrices I had with me, and oh yeah, the small mini consoles. Maybe I can show off the badge. Wait, where is it? Yes, it was cool. What is that? I got Maybe I should look inside of my bag what I got. Oh, I got plenty of goodies. Oh yeah, that's a multimeter. Let me show the goodies. Here we go. This is the swag bag. That's an simple add-on multimeter. Yeah. So really cool design. I love it. So simple. Look at that. You have like the front cover is a PCB, and then there is like a second board underneath that. And yeah, there are some terminals. Probably have little assembly to do here. Knobs, terminals and buttons, and the probes are here. Oh, they're quite pointy. We might want to use the... Oh, this is so cute. Look at that. They just look like the 4mm ones, but are smaller. What is this? 2mm? The probes. That's cool. Yeah, it's powered off the back here. Cutie thing. Let me check what else we got there. Oh yeah, there is like simple add-on breadboard or perf board. Oh yes! Oh, that was sweet. So Seed was one of the sponsors of Hackaday, and there was like a marketing person, a woman that was showing all the what is she what's the name? The sheep who can pronounce it correctly. The show. Yeah, the shows. Oh, there is another. Oh, so there apparently there was a show in the bag. Here is a show. Which one is it? ESP32C6. Nice. Right, so I got the C6 and I asked her for samples. So I got this one. So she didn't have samples for people, for handouts, but then she approached me later. What? You didn't get a show in the bag? What? The Shipu! If I knew, I would give you the one from the bag. Yeah, and she gave me like an extra one with camera. And there are some heat sinks. Look at the heat sinks. They're cool. That's the ones that we needed initially on our drivers, huh? Is this an antenna? What kind of antenna is that? So yeah, I like the format, and since they made a standard for themselves, the bags were inconsistent. Yeah. Look at that. So the Shipu's designs are always compatible with the Xiao's. Here, Wi-Fi. Let's plug it in. Should I grab the bigger camera so you can watch? Yeah, let me grab that camera here. I was recording a lot of stuff during the assembly of the M.2. So I have a ton of material, but it didn't work. So I already submitted the next order for a new board that will arrive next week. I found an error, more on that in a few moments, I guess. But we will do more designs because assembling a complete board like that, which is highly integrated, for an hour, then finding out it doesn't work and all the work was for nothing. I use this one here with an external power supply at my debugging connector here. Wait, I just connected the camera. Let's use that then. Can we use the camera here? Where is the camera? GH5 here. And use some autofocus. Okay, here we go. Maybe we switch to ISO 800. Here we go. Okay. So, yeah, I had some programming pins, so I have VCC and ground on the back. Yeah, populating them in steps, but if I apply the solder paste, it will be dried before I finish testing here, or it will be difficult to, or I have like to paste only this part or something. So, and there is also like one thing with Timon's footprint that we imported. There was like the paste mask wasn't set, or let's say it was that the pins were open to the solder mask, so I have even like some solder on these pins here. There is no short, that's all just one ground, so 3 pins ground. If you're looking at that and seeing, oh, there is a short bitluni. No, it's all right. It should be like that. Other than that, we forgot to put in the manual tabs. That's why we heat tape. Oh yes, true. Yeah, I have Captain Tape here. Captain Tape for rescue. Yeah, I did a leap of faith and landed on like this dude who jumped in this lake and it was frozen in the end, and then he hurt his back. Yeah, that's me. Basically, what did I want to say? Anyways, yeah, I fixed that. I added manual tabs to the footprint of the board. Yeah, so after this didn't work, I populated just the parts of the serial part. So I wanted to see if it is something to do with the other microcontroller that's connected over serial, and it wasn't the case. Behaved exactly the same, but I found a mistake. Now we are to the topic. I found a mistake in my symbol that I made for the M.2 MB key thing and the PCI Express one. And there is like the view from the host side and from the device side. The one like PCI Express has also transmit and receive lines. The devices transmit receive lines, which you connect vice versa. And you know what happened? I flipped the transmit and receive lines, unfortunately. Null modem again, yes. But only for the first PCI Express lane. So the second lane and third and fourth, everything was correct. It only was flipped for the first PCI Express lane. I don't know if this was the issue. Might have damaged the chips because I plugged them in before testing. So that might be one thing that we can debug today. Just putting on a new chip, powering it up and seeing if still behaves the same with the 3.3 and with the 1.8 volts here. We can limit the current on the PSU. We should have done it before and just like that. Anyways, yeah, sad story. I ordered new batch of boards, and one funny thing. Let me switch the lens though, because this one has no zoom. One funny thing. Now you get blind. You get blind. blindsided for a moment. Ah! LDOs, what? What is... What is with the LDO? Go on. Here we go. We should be back. Huh? It's blind. Oh. Doesn't work. Oh yeah, I have still the cap on. Let's open the cap. Here we go. I can see now. Yeah. This is it. Wait, what? Oh, what? The lib code. Ah, all right. Hey, Carlos. Don Carlos, Carl. Here we go. Yeah, so that have been the issues with that. Oh yeah, one thing, I talked to a few people who are more experienced with working with the differential pairs and high speed on PCI Express, and they told me I don't know what the dude's name was, unfortunately, because he was really cool. He clarified, or he educated me how to actually route PCI Express lanes, and look how nice it looks now. So these are more or less length match. Yeah, lengths are almost matched here. I think I used it manually, so we can check. This is 6.5 plus 2.7. That's like 9.2 or something, and this one is 6.7 plus oh wait, that's even longer, 1.7. So that's all right. I mean, it's more or less the same. That's an issue, because this is like, we need to flip them. I don't know why on this chip specifically you have all like clock is plus. Why is it so strangely zoomed here? Oh wait, here we go. Clock is plus minus, the receive is plus minus, but transmit is minus plus. What? So we need to flip that. And I checked with well, on the reference design, it's also the same. It's even harder to do it on PCI Express. They wired all the lines on. Yeah, one important thing to know is there is like they told me, all right, there is always some ground in between, like the out here's power, that's almost as same as ground, but there is like always ground to be able to have basically the root back for the power, which is same length, and the best case is to have an uninterrupted ground plane, and this is what we got here. I mean, it's maybe I should have had the via closer here, but I tried. I have like on 2 planes. Okay, that's a mistake. I should have had the via here, even though I have on the back some other traces. But still, like, there is some ground planes, and especially for this here, I have like even traced the ground properly between those 2 differential pairs. So we should be alright with the clock, the receive, the transmit isn't that important. it will negotiate some proper speed for that. Anyways, if you compare it to the old design, do I have, yeah, I stored it under LED matrix wrong. This was the old design. Does it load? Yeah, it loads. Hey, DHC. So this is the old design that we have assembled here. Yeah, there is no such thing as an uninterrupted ground plane. Transmit and receive is flipped. So this was the mistake on this one. So these are the receive lines, not the transmit lines, and these are the transmit lines. The new design is good, Steffen. Impedance, I don't know how to do that. You can walk me through how to calculate the impedance. We can try that. If you show me how, did you do this with KiCad before? Anyways, the old one, yeah, there is no such thing. Only interrupted ground planes like that. I think these planes weren't even filled. Like this, we had just the back plane, which is basically trash. So there was nothing. It would be bad. I mean, it would work with. A calculator. Okay, so let's check it out. We can try to calculate the impedance. How do we calculate it? Let's go to the. How do I calculate that? Place tools. Inspect. Altium Designer. Yeah. Separate app. I mean, I ordered it anyways. We can check, but KiCad impedance. Phil has a tutorial on that. Oh wait, oh damn. I wanted a specific topic. Wait, where is it? Next step, schematic, fine. What was it? Oh yeah.
Let's talk about controlled impedance traces.
Okay, let's see. Dielectric. But I didn't set up like the layers correctly, I think. How do we use that? Okay, we have that information. Ah, here we go. Wait, that looks like PCB calculator. Okay. Okay, wait. Calculator tools. high speed transmission lines. Oh, come on, this is physical. Okay. How do we find out? Okay. ISLA, let me check. 0.8 millimeters. Okay, we have, I think this is 150 mil. And let's, yeah, oh, 125, okay. 100 physical length is, let's take this one here. That's 7.5. 7.5. Then we have substrate parameters. Oh, come on. What are we doing? Oh, wait. Where is it? Oh, yeah. Differential pair. Where is it? Twisted coplanar wave. Huh? Oh, we have this as well. But where is differential? Coupled microstrip line. Is that? Coupled microstrip line. Is this that? What we're looking for? Okay, here we go. Stefan, that's helpful. Width is 1.25. S is the, I think it's the same, yeah. 1.25. Length was 7.5 millimeters, and now we need the parameters, the PCB parameters. Okay, we have stack up data here. Copper, (18 micrometer copper). Damn it! What are those numbers? What is this? Dielectric constant. Is this Innig gold? Dissipation factor. Okay, hey, height is this. This is 2 times 69. What is this? Is this the copper for the... Yeah, this one, 69 plus 69 is 138. 138. They say, but it's all right. Okay, maybe there's the glue. Okay, so anyways, and what is this? 30. This is 40 micrometers. T. That's 40. That's not that bad. Dielectric constant is probably gold, huh? Oh wait, that's the dielectric. That's this stuff here. What do we have? Panasonic. Where's the constant here? Oh, 4.3. Okay, let's use that. 4.3. Then what is this? Directed loss dissipation factor. I have no clue. Let's leave it the same. Roughness. Conductor. What is this? Microconductor. Can be ignored. What is our... Okay, let's start with 100 megahertz. Where's the calculate button? There is no calculate button or what? 1 gigahertz, we do 1 gigahertz. All right. Analyze. Uh-oh. 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 What is 10%? 10% what? Huh? What does this say? Impedance 119 ohm. Delete the gap value. Is this the gap? No, loss. Where is the gap value? Which gap value? Why do I delete it? Not a number. And the gap value is for sure one. Look, it's the same. If you look, that's exactly the same width. Heaven. What is? Oh, I want 100 ohms. All right. Okay. What happens if we do this? It's the same. It doesn't matter. Calculate the gap. How do I calculate it? Anyways, it's looking good for the new board. Should we record that? Okay, so I'm recording for the video. No, what happened? What happened? I don't know where to calculate the width. Why did it appear like that? Reverse differential pair signals. physical, but the width is we have 1.25 distance, wiggle gesture, yeah, looks like that. And if we okay, I give up. I recorded the results. Okay, no, here, let's record. Oh, okay, so I can basically, if I want, let's say if I do 1.5, then it's 100. If I do like 0.2 millimeters, then we have, oh, so I want something like 1.8 or some, oops, 1.8 is too much, 1.9. So basically I try to match 100 ohms. So 0.2, I should have known that beforehand. Okay, so 0.2 it is for the next, yeah, I got it, thank you. Nice. Oh, this is so complicated. Okay. Anyways, so with this 0.8 millimeters stack up for from Eisler, this one here, we need like 0.2 millimeters if we keep them so close together. But this is like the minimum distance between traces, I guess. Yeah, I learned something finally. Rules. Here we go. Copper. Here we go. All right. Yeah. All right. So this spot looks a little bit better, and this might be like the transmission line might be not perfect. I didn't length match it properly. Just eyeballed it. Maybe this got too long at the end, but anyways, this will be fine. I guess so, especially since transmit and receive isn't flipped anymore. Yeah, that was that. Hey, Ghetto. Is that a PCI Express to USB converter? No, there is no USB converter. So this is the other stuff. I have a PCI Express to serial bus, not USB. USB would be a nice thing to have, like instead of that. I'm open for suggestions for different chips. Obviously, Texas Instruments has some PCI Express host controller that we might be able to use, like TUSB 7 blah blah blah. Yeah, oh, what is this? That's way too many pins. No, I refuse. All right, but it's so hard to find them on DigiKey or Mauser. Use the US media, PCI Express to USB. PCI to Terran, what? Parallel and SPI. I like parallel as well. As many parallel. The best case would be what we have there in the PC. Yeah, that's hard. So yeah, these chips, I want to make one with this chip as well, or at least the other one, the big one, since we discovered we made some firmware for that. Yeah, that's so terrible. I try to find like chips that are capable of doing that. And hey, Mormon. Here, let's take a look. Ask me with assembly, yeah. Yeah, that's that again. So I try to find interface chips. One thing, you know, the best way of finding interface chips is to look at D-Log's page and check out the chipset that they are using. No, I want I want a USB, PCI Express to USB, and then to micro. So there's like, if you look at that, oh, that's you collect D-Log PDFs, yeah. So basically, if you have like USB, then you go to that. We can take like something super cheap, and then go here. Oh, damn it, that's too many. If it's too many ports, it will be a too big chip. Oh, there is... But this one has a like super big heatsink. What kind of stuff is that? Okay, technical details. And then you just check the chipset, and then you look for the chipset here. And try to find it, ASICs. But there is like, no, that's the... Some M.2 have USB. Is that cheating? Yes. Yes, no. Lasse, the problem with that is only like the shortcuts, the small cards in laptops and so on. That's a different key. I have only the SSD key available, which is M, and the M key doesn't have USB, or it's like rarely that you get a USB on that key. I think it's not even specified for SSD slots. Yeah, E key. Yeah, you. Yeah, so I don't have an A plus E key. That would be the easiest, of course. But yeah, if you know a simple chip that the best chip would be the same that we have from like, it's this interface WCH is a little bit like strange, because we have like to latch our outputs currently. I don't know if we can find a mode that's better suitable for just driving the IOs. I want tri-state IOs and as many as possible. Yeah, but you can't even get Renesas. I found also a chip from Renesas, but you don't even get the data sheet if you don't log in on their site. Commercial use and sale. Yes, that's the problem. This is so strange. Artem, that's what I mean. It's like really strange. Why is it so complicated? So we're stuck with WCH. So strange. I don't like it. I don't like it. So that's why we put up with this for now, and I hope the next revision will work. Apparently there are some warnings from my DRC rules checking here. Oh yeah, look at that. I did. Oh, there's a recommendation. You don't fill the pads. Pain in the ass. Yeah. And yeah, here the manual tabs. So we won't have like tabs here, the mouse bytes. But the mouse bytes didn't matter so much. All right, so that's that. We wanted to check out this stuff here. Wait. So this is the show, and it has the camera module. Wait, this is, yeah, we have the antenna and the camera. Which one is it? What does it have? What is S3 sense? What? So it has even a sensor, maybe? No. You can attach just. Oh, this is so cool. Look at that. Okay, let's plug in the antenna first. It's so sad that it doesn't have like a PCB antenna. I would love to have a PCB antenna on that. Oh, I don't want to break this. How do you plug that in without damaging it? It feels a little bit... Ah, it's plugged in. Okay, here. Look at that! This is what? This is tiny! Nice. Yeah, so the hello to the nice girl from Seed that gave me this sample. Sweet. So I have an S3 and a C5 now. But what do I get the heatsink for? Is this for... Do I glue it on that? How do... I don't know why we need that. Heatsink is for the camera. Yeah, alright. So you need to plug it in like that. But we have a second heatsink. Is this for the chip like that? And it's double the size. Yeah, cool. Yeah, the Shipus robots. This is perfect for that. SD card and slot. Yeah, there is no SD card and slot here. Ah! Yeah. Hacker mode activated. So this is the cool. Let's check out that one as well. Oh no! I lost the headers. What? There is an SD card slot even on that? You're kidding me? This is like a spy cam then. Oh, you're right. Here. There is an SD card slot. So that's like a spy cam. I will put it like here. What are you doing? Nothing. Just roaming around. Just hanging around? That was hanging around. I messed up my meme, damn it. Anyways, oh, there is like two headers. They need to go in there, I believe. Yes. We have two headers in there. That's amazing. I love the design. It's so compact. Nice. Good job, Xiaomi. Not Xiaomi. Seed Studio. It's the Xiao, but not me. I feel it that I will learn Mandarin at some point in my life. There's like two antennas. Nice. C5. Is it C5? C6. Yeah. C6. Nice. I like that. You know what? I think this will be my board to go, since they ship from Xiao. Look for Xiao. 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 Xiaomi. Xiao. 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 Which one is it? Okay, that is throwaway, but I think Seed Fusion Service. Oh! And Xiaomi? Is there a translation? Small friend, or what is it? Speak Polish. Xiao. Xiao. San. Xiao. Xiao. Xiaomi. We have Cyrillic. All right, let's check out more from the back. Rice. It can mean rice, depending on how you xiao, xiao, xiao. Oh, what? Oh, grain. Oh, so like small grain. Maybe that's why they call it Xiaomi. You have so many of those devices, like grains of sand on. Oh, that's this thingy. Wait. Where are there any screws? It didn't came. Oh, here are the screws. This is like this. How do you call it? What's the name of this thing? This is like the. Oh, why? Look at that. Someone actually made the contacts. In Vietnamese, it's a noodle. Okay, I will not assemble that right now. We might do like a casual stream when I'm not feeling well. Today we have a full program of stuff to do. I showed you the stuff that's wrong already with our PCB. This is again the small multimeter. Sweet little thing. There's this. Oh wait, that's my shirt. Nice, this is the shirt. Yeah, it doesn't work. The design doesn't work. I hope the new one does. That's it? No, there's more. Wait, there's more. Oh yeah, that I got that from some dude. I forgot the name. I hope I don't. Here, scan this. It's a USB relay. Someone gave this to me. Just a private handout. But I have something else that I got from a nice person. Wait, where's my backpack? Oh no. Oh no. I destroyed. Oh yeah, I had also my mod tracker with me. But wait. Oh no. I had the cards here. Pedro, he's living in Portugal. He works for Espressive. He gave me this thing. And if you open this up, I usually don't like to take handouts, but I take any handouts from Espressive because, yeah, look at that. I thought it is, oh, nice dev board and a camera, classic, but wait, is there more? Oh, Fortuna, there is a whole display. What? This is like, this is some serious dev kit here. Cha-ching. Yeah, cha-ching. Ah! I didn't, oh, so this is live. I never enabled it or anything. We can just try it. What the, this is freaking huge. Who is blocked? You're not blocked. Are you blocked? Do you want to drop a link? If you want to drop links, you need to have admin rights. Here we go. There is another. There are two. Wait. Is there a second protector? Yeah, I hope so. There is a second protector. But alright, there is this flat flex. That's the LCD. Should we assemble that small side project and enable and see what's happening? And then I hope there is no trolling stuff on there. What is this? Do I need to connect it as well? I hope not. Alright, we have some standoffs that we can connect like that. So I guess... Oh wait, that's still... Oh, there's still the pick and place stickers on there. So if you don't know, there is like pick and place machines. Since this is SMD, apparently, it looks like SMD. It needs like to suck in this part. Oh, wait. I give you the rights. You can post the link in a second. Wait a second here. Okay, you can drop the link now. ASM 1142. It sounds familiar to me. ASM. Was this diode incorporated? Okay, we need some more standoffs here. Which one do we use? Wait. Us media. Wait. Why do I... Why? Wait, how do I need more standoffs? Wait, is it like this way around, maybe even? Yeah, looks more like that. Okay. That's display, MIPI display. Which way around is it? This way. Okay, let me assemble this. But you know what? Whenever I get dev kit like that, it's overwhelming. That's way too many stuff or many possibilities that you have. I want something. I would rather prefer to have a simple dev board just with all the I/O exposed in the form factor of the Xiao. Ethernet, yeah, the S3 or the ESP32 already had all the. Okay, and I think no. Do you put this also there? I think we remove that. It's certainly a nice score, so thank you, Pedro. Okay, I will check that out. Oh yeah. It's QFN, which is amazing because I hate those exposed chips and I don't want to use BGA or anything. Alright, so already scratched it. Stefan. Here we go. Power. It has host, power, and device. USB word power in. Okay, let's do power in. Wait, this is not power. What kind of crap is that? Give me more power. I guess I need something more potent. So let's. That's all right. If you help, you can use your affiliate link. With paste, it's all right. Okay, let's turn it on. Oh, camera isn't plugged in. Do I need to upload the sketch myself? There should be at least some blinking stuff. Okay, let's plug in the camera. Where's the camera? Here. I hope that's like nice capacitive touch. Here is some camera. Did I plug it in right? The blue thing is on the top, I guess. Like that. Or is it wrong? Okay. Where's the camera? Huh? Wait. Did I use the right port? Huh? Where's the camera? Didn't we have 2 ports? Or is it only 1 port? No, there is the camera. Oh no, I need to disassemble it again. Power in? Yeah. When it's powered, okay. Let me disassemble it and then plug in the camera. You know what I would use that for as a home assistant? Put it on the wall And then it needs to be flatter though. I would like a super simple tablet that runs Home Assistant in the hallway, so I can screen should be supply by its own, or is it? Yeah, it looks like it needs some power here, but I hope that is supplied by the wait, no. Am I stupid? Here's the camera. Oh, what I saw is this here. Please. You didn't see anything. Psh, psh, psh. Hey, Stefan. What I'm trying a dev kit. Backlight. Wire reset LCD and another for backlight PWM, yeah. Yeah, I guess we need to use those Dupont wires. Yeah, it's probably easier to use. All right, okay, we have okay. Okay, GPIO 27 5 ground. Okay, let's do it ground and 5 volts. Then we have PWM and the reset LCD. Yeah, it is P4. Okay. We need 5 volts ground. Make sure we didn't flip that. And that will be a reset as 27. $27, $26. All right. Now let's turn it on. Nope. We need to. Oh, wait. It's not plugged in. Here we go. Boom. Music player. That looks like a system. Does it have a buzzer? I can't hear anything. We probably need to connect Bluetooth first. Wi-Fi. Okay, how do I go back? It's certainly touch control. Is there an aux? Speaker. Oh, there is a JST for speaker, or at least like a connector here. There, this one. All right, something for Elisa. Yeah. Oh, it had screen orientation? No. No. Didn't see that. Wait, how do I go back? Okay, what is square line? What's camera? Let's check camera. That's our M.2 board. It's way more advanced than expected. Oh, that's quite a nice frame rate. Yeah, it grew. Normal detect, pedestrian. It detected a face or what? It has some face detect. How do I go back? I want to go. Okay, what is square line? What is smart gadget? Okay, we got some time. But the seconds indicator doesn't. What is this? This is wrong. The clock is wrong. 9:25. Well, nope. Ah! Someone's calling me. Ah! I don't like phones. Ah, yoga class. Okay, here we go. Yeah, I'm introvert. Oh, nice. All right. I played it on an airplane during my vacation. Oops. Ah! Ah! Damn it. It fell apart. Okay, anyways. It's alright. What do we have? Settings, Wi-Fi. Turn Wi-Fi on. No, I don't think it's running Android. Wait, it's wait. It's way too bright for you. You can't see anything. Okay, we are connected with the Wi-Fi. Probably now, the clock should be updated. 9:25. No, it's fake. Ah! No! Go away. Okay, what else do we have? There's nothing else on the page. Okay, that's the P4 for you. Yeah, do not like. Go away. Leave me alone. Ah. Okay, so that's the kit. Nice. That's way too overwhelming. I just want a chip. Let's take a look at the chip though for a second. So it's huge. Extend my insurance policy. So this is the antenna. No, it's just no. That's a different crystal. We have two crystals. Probably one is real-time clock. What is this? Wait, there is a C6. That's the C6 module, probably for Wi-Fi. What? Or Bluetooth and Wi-Fi? Because that doesn't have a connection to any antenna. So wait, but the P4, does it have Wi-Fi and stuff? Okay, now I need to check. Oh, tired all of the sudden. Okay. High performance system on chip. Okay, let's see what it says. Rich human machine interface. Okay, interface. Oh, high performance. Dual core RISC-V 400 MHz, which is nice. Single precision FPU, AI extensions. What does that mean? What does AI extension mean? ZigBee. Okay, let me put this back in the case. This will be yet sellable. Too tired of lag progress? Yeah, that's certainly that. Wait. Oh. Let's put it in my shelf and we see it in 2 years again. Okay. I don't like the interactive page. Highly integrated peripherals. Best in-class security. Okay. Software availability. That I can assure. Dev board. Look at that. The Wi-Fi module is extra. Product selector. Okay. Let's see. Wait. P series. RISC. Reason? There's two crystals. Yeah, one is probably low power, 32 kilohertz, and the other one is 8 megahertz or something for the core frequency. We have 128 kilobyte HP ROM, 16 kilobyte LP ROM. Oh wait, Stepan, I give you admin rights here. Wait a second. S 768 kilobytes second level memory. That should be enough for everyone. That joke. Only dads understand that. 32 kilobyte LP, what is low power SRAM? And 8 kilobytes of TCM. What is TCM? It has either 16 or 32 megabytes of PSRAM. Oh, so it can serve like any C chip, but do you need to program them both? I like that it has all the memory internally. I like that. Oh, low. Yeah, the GUI, yeah. Yeah, you're right. Yeah, that's PSRAM. 100% sure that's done with PSRAM. Need a CPU, okay. Gotcha. So actually this chip, I like that. Let me, oh no, S-series, wrong, sorry. Yeah, laggy. Yeah, it's not super fast. Is this the only MCU? Okay, let's get datasheet. I want to know how many pins we have. Where's the datasheet? Where's my datasheet? Huh? I want a PDF though. Not the S-series, dudes. H. Not H. There is no datasheet? What? Wait, P4. Other. There's no datasheet. Okay, but we can use that chip in future, maybe. If it's a beast, if it has certainly enough like RAM stuff and so on. How expensive does it get? Oh, sample request. Anyways, back to our projects. So last time, let me turn it on. We are at the PCI Express stuff thingy there. Let me set up the camera properly. Oh, this PC is so noisy. By the way, STM, but what's the price? I take the cheapest one. Yes. You know, I really enjoyed setting up the PC last time. It was a challenge for us to get it running. Wait, where is it? Here. It's starting right now. Oh, barf game. Here we go. It's starting. Can I? You know what? I put it just on the side so we can look inside of that. I just need to take off the screen and There's so much mess on my table. We can just place it. Oh. Ah! Fuck. Cables everywhere. Need to undo this one here. Yeah, fair. They lost me. I'm not interested anymore. Shoot. Ah! Oh yes, that's way better. And it's also not as noisy. Okay, now trash everywhere. Here we go. This is how I place the camera. Wait. Okay. We ran that. Is the stick still inside? Yes. Okay, here. Auto run. No, huh? What? Where's the executable? Oh, Looney drive. Here we go. Main. That's what we did last time. We managed to run this code, and it's using a latch. And oh, interesting. Okay, let's take a look at our desktop and our code. Here we go. We are now IO address +0. Nope, just writing to 0 because IO has built in. Thank you for checking that. Specify IO port address. Word double row read mem by dword configuration space write config access block read IO port. Wait, we have Oh, what was the ASRock chip again? AS. I need to. Oh, wait. Is this ASM 1184? Because I think I googled it already. No, that's the switch. Wait, what? No. Let's check. PCI Express bridge. Oh, I have 82. That was a switch. 82. 42. Oh yes, that looks cool. And who guessed? Who guessed there is a D-Log card for that? Doesn't load. D-Log doesn't work. It's a PDF. Yeah, anyways. China. So, here, ASM. Oh, they had some issues? What kind of issues? Are they solved now? I'm wondering if you can get the... Oh, you can't get the chip standalone, just of AliExpress. Okay, I will check on eBay. Sorry, not sharing my screen that I'm using for that. Now you can only get a card for that. Wait, the cards are so expensive. What? 20 bucks? No. And it's shipped from somewhere else. PCIe USB. Oh, interesting. If we look at that, there is IC box USB-C. Oh, this is more expensive. Digibot. Oh, here we go. That's probably also running the same chip. I can see it already. Some SATA. Here, 10. That's running probably the same chip. So can get for like 10 bucks. Oh wait, this is China. I don't want from China. I want, yeah, 17 bucks from here. What is this? Oh, from Germany, 4-port USB 3. I just take that chip, I guess. What kind of chip is that? VLI. Okay. VLI chip. What kind of... Look at that. I think I saw that chip. Let's zoom in. I can't zoom in. VLI. Of course, it's underspecified here. Is there any specs on the chipset? Doesn't say anything. What? That Amazon $10? That's also VLI. Yeah. StarTech. Let's check that. It's probably the same. Oh, save and continue. What's this? Yeah. Did you find it? VL805. It has. Look at that. It has an internal one and 3 external. It's the same chip. Yeah, this one, €41. We just want to see. Yeah, VL805. Here you go. So this is how you find Mauser. Yes. Whatever. VL. Digipart. One. Okay, thanks. 4 Come on, Moses sucks ass. Let's go DigiKey. Nope. Why is it so hard? Via Labs. iOS out of the box. Nice. Yeah, so it's not obtainable. What the F? I hate this. Why are all those chips not available? It's so terrible. I like the footprint though. Look at that. Oh, some nice differential pair. And SATA. Quite some stuff there. TX-RX clock, megahertz. Can also buy washing machines and these sort of chips here. Actually, that's what I would do. I will buy, just to get it fast, I will just buy one card of eBay that will arrive in 2 days for $12, free shipping, or of Amazon for $10, and then just take off the chip, and whatever I need for this chip to run, it will be in the vicinity of on that PCB, and can even take an example how it's routed correctly to the PCI Express. That's what I'm going to suggest. Yeah, that's. But if I want to build more of those, why is it so difficult? Yeah, that's a way I like to source sometimes. All right. Anyways, back to our thingy here. Yeah. I will take all the nice Patreon money for that. Maximum length continuously read. What is this? Access mode. Access modes. Access block. That just if we can completely transfer blocks or what? Yeah. Oh. Metaverse Incorporated and query in stock. 50,000. Captronics. I should use Digipod more often to find out who can source it. But I don't know all those companies that have it in stock. Okay, so what did we find out? Apparently IO address is already on there. Now this is 0. The word. Ah! I should scan the whole thing and be E. B is not byte anymore, it's a double word. Double slit experiment. We should see, we can maybe attach 100. What is this 100? We can run indefinitely. We should run on 256 at least. That will be 32 times whatever. Okay. What was the build process like that? Build was done successfully. Because I wanted to check maybe with the oscilloscope what's going on there. I have a digital oscilloscope that we can check. Oh no, how do we access that card? Can we, is it hot plug compatible? Can I just unplug the card and then attach the digital probe? $200? What? Why port 200? What is so Terran, where did you, let's talk about also utsource.net. What where did you find what information? Any port does same thing because there is no address decoding on I/O. All right. Let me copy copy the new file. Oh no, I ran it on accident. Is there a mode where I can just turn on the pins permanently, like change the mode? I don't want to latch it. I want to use it because I want to find out a way to avoid those latches, the flip-flops that they used. Let's see. Let's see if it blows up. Where's the camera? Interface with the correct strobes. Huh? Oh. I did a mistake. 31 in the code. Interface with the correct strobes. IO right. The LED just uses IO right. Yeah, but what do you mean with? I mean, compared to a regular microcontroller, I would like to have the access to data and the address lines, just like tri-state. Maybe we can just also set it just to output. I don't care. Why do we need like to strobe or there is not such a thing? We can't do this. Can we access the address lines or only the data lines with the strobe? Because that limits ours a little bit. Yeah, but I didn't read it. I have it, but I didn't read it. That was your homework. Let me check again. DS1 PDF. Your test? Where's your test? What? Okay, yeah, this will be running. Let's do this stuff. Okay. As long we don't write to a random memory port. Here we go. Huh? Stick not recognized. What? Oh no. Yeah, now it's recognized. It's slower. What is that? Oh wait. Shit. Ah! It was only a quick blink. Bye bye. Oh, you can certainly. It's up to date right now on my GitHub with the last blinking with write byte. Now I just changed to. We can do. We can just invert it. And, tilde. Let's use just one. I need a better solution with transmitting. How do I share a drive between two PCs? Because that's the last bit where I want to roll over. It's 32 bits. It should be at least. Know what I mean? Oh, it's not. I write a double word, or is it wrong? I'm using the 6.8 card, not the 6.7. Look at that. It should be like writing to, or is it writing sequentially? Just writing to 8-bit and then strobing. Yeah, you can write to any data line then. Not? Okay, wait. Should be able to write write a double word. What? Why is there a double word function then? You check the code. What kind of code? Where did you find code? What kind of code did you check? Can you link that so I can get an impression? Oh, really? Yeah, but on this card, the data port is 32 bits. It's the 32 bits card, not the 8-bit chip. It's the 8 version, not the 7. Yeah, it works. It works with 32 bits. Now it's correct. Was some strange overflow error. It's just going through. Yeah, that's it. Look at that. It's going through all the 32 data pins, but it's only showing the first 4. I can show that. Okay, let me start again. It will just repeat after 32 bits. And I will show that on the oscilloscope. Let me set that up. We'll just repeat in a second. So it's running like 32 times this one. How can I get this device out? Okay. We'll set up our... What's the point? I want to use the data pins as latches. And I also want to use the address as and I want to use just the whole thing as GPIO, not like a memory interface or anything. That's my point. If we can run an LED matrix of that, we'll just add those D flip-flop ICs to all the data lines. Then we have already 32 IOs that we can set LEDs without the microcontroller directly from PCI Express. How did you calculate the FPS so fast? Oh shit! I just dropped mine. Yeah, I will add the D flip-flops, not Not drivers, because I will just run it low current, I believe. Maybe you can run one by one at high current or I/O chips in tri-state. Yeah, so we could do that as well. Low power decades ago. Okay, where are my digital probes though? Uh-oh. I found my digital thing, but I don't see the probes anywhere. Let me check. Bitluni searching stuff. You like that theme. But everything is cramped here because I was just like in this corner. The oscilloscope corner. Uh-oh. I don't see it. Oh no. Tiny, I think tiny. Oh no. I don't know where my probes are. Damn. Huh? I have no clue where this could be. Under tilted PC, yeah, maybe. Let me check here. Here's some probes. Nope. It's probably stuck to some project that I did long time ago. The parallel interface. How do I use the parallel interface? Terran. How does the parallel interface? This is the I/O interface. Okay, I can turn this off because I don't have the probes. I have no clue where they are. Too bad. Might be somewhere here on the shelf. What's the difference with the I/O interface? I thought both. Oh, okay. Wait. You're kidding me. There was always the option to use it like parallel. Like I wanted it to use before. Like GPIO. In and out. I don't know where the probes are. Ow! 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 Yeah, but it's the same. I tell you. If you open I show you the data sheet and then you will Wait, this is the... No, 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 wait. Here. Maybe you don't have this data sheet. Look at that. Yeah, so if you look closely here, okay, so this says D1, D2, D3, I mean here, D0, so connected is D0, D0 is here. This is just a digital interface. It's only using the first 4 bits of this 32 bits. But it's basically the same thing. What? Why 1, 2, 4, 8? 0, 1, 2, 3, that's that. And these are the first. So what my code does is just, it's inverted. So let's assume it turns on no. We can do it hard-coded. Should we do it hard-coded? Yes. Oh, you mean the value, not the bit. Oh, you... Okay, yeah, I agree. That's the bits. But 32 bits will turn all those data lines. So that's why I'm using double word. Yeah, no, that's all right. So the I/O, it's just accessing this here and it's letting that out. We only see that on the LEDs because only the first 4 bits are reflected. Like you say, the values whatever. But I'm using write double word, which basically sets all of those at once. So we are accessing all 32 bits with I/O right now. The question is, okay, how do I use the address bits as well? They're not the same. What does memWrite do? Mem is just using the memory interface, like the setting the address and then spitting out the data. Am I right? That's just the implementation for the memory interface that this chip is supposed to be doing. But I just want to access like we did with those pins here. I want to have this for all the pins, including the addresses. Different strobes. So basically, okay, so where does that say? Can you tell me? Okay, there are 3 types of spaces. Did you get it from here? Memory space, I/O space, and configurations. The memory space mainly includes memory, video memory, expansion ROM, device, buffer, etc. Used to store a large amount of data, exchange data blocks. The I/O space mainly includes the control register, status register of the device, which are generally used to control the query, the work working state and the working status is to control and query the working status of the device and exchange a small amount of data. The configuration space is mainly used to provide the system with basic information about the device itself and to accept the system's control and query of global status of the device. Yeah, we will test that just in time. In order to avoid address conflicts, PCI Express requires address occupied by each device can be relocated, relocation implement, blah 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 blah. Memory space of occupies 32 kilobytes and the offset address is 0 to blah. It can all be provided to external devices. The actual address is the memory base address plus the offset address. The O space occupies 256 bytes. Okay, self-use register. If the self-use register is removed, can be provided for external devices to use the offset address, actual I/O base plus offset. Okay. Yeah, and one of those will be address as well. So I guess like the first, if we like. Let's skip this for a second. 200. What is on port 200? Configuration I/O base register. That's the standard I/O port. 200. Yeah. General purpose output register. Okay, let me variable input register, throw register. Okay, that's like some more space. Data registers for passive parallel interface. Address setting register. Right. Passive reserved. Memory data access register. Okay. Hardware loop count register. Reserved. Okay, whatever. Okay, let's do it. Let's do it. Finished with warnings. Yeah, because it's warnings are fine. Let's fix the drive. Blah blah blah, Mr. Freeman. All right. I will copy that now. Okay, moment of truth. We are writing to port 200. Yeah, it's the same. Same. I'm wondering if we get more than that. I would really need a digital probe. Otherwise we might be screwed. We can still do the design though. I will use LEDs. I want to use just LEDs. This chip and then the D flip-flops and then LEDs. Same array. I just take our M.2 design, put this chip on there on the back side, then use the I/O port. Thank you. But I'm not sure. I mean, we will be. I don't know if it works. I need to approve that to prove that it's actually 32 bits. How do we prove that it's working with 32 bits though? Decode address lines? But what? Okay, let me read more. Passive parallel interface. Oscilloscope, yes, I can do that. Let's use then simple oscilloscope though, and try to find the bit. It's so sad that I didn't. Dangerous prototypes. I don't have a logic analyzer. That's the issue. I need no address decoding. I just wanted to use the address as additional bits. That's my goal. I just want to repurpose GND. What can you? Yeah, let's share how I destroy my PC. So GND, where is the address? This is address line. Yeah. On this it is. I have like 2 rows. Let me show that. There are 2 rows. Do you see that? And right next to that I can already see the address lines. So on the top here we have the address lines. So basically probably the other ones are the data lines. Do I need really to shut it down? Maybe we can just put it in sleep. Hibernate. And then pull it out. I got, by the way, I had so much fun. Yes, it has some power in sleep, but I don't care. If it blows, it blows. Here we go. I have D8. Okay, D8. So D8. Wait. So you know what I told you about the PC? It's from the photography shop. From my mother's former, and this is the same thing but older. It has even like a disk drive. I don't know what CPU is inside there, but the fan is like minuscule. So this is like probably, I don't know, Pentium generation 2 or... Hey Dutch! $486. Yikes. Even the handle broke off. But this only has PCI, not PCI Express. It has DVI though, so I don't know what kind of PC that is. But it will run Doom. We will do a fun old PC. Oh wait! Huh? What is... There is an Intel chipset. P5. Pentium 5. Let me check the date. If I can find a date on this PC. It has a Windows XP Home sticker on the back, so it's XP. No, it's a Windows XP. It has to be some sort of better Pentium. Okay, so if it runs XP, that's all right. We have a potential Windows XP PC for exploration. What shall we do with that? Does it have... It has... No. It has a slot for FireWire, but it doesn't have FireWire. Xcompile might be hard. Let's Xcompile. Okay. So I connected D8, which shouldn't be exposed on cross-compile. Maybe, you know what? I do more. Okay, I will add some address lines. Okay, address lines. I will just add some random D20, D30, D31. Okay. We hoard. Yeah. We will have a server farm. Okay. I just connected. Ah! Oh, maybe we should add a line to the right. No, I don't want memory functions. What is the thing that latches? How's it called? The latch thing. IO write, IO read. Oh! A sub! Max! Thank you. Okay. We have interrupt pin, then we have IO write, IO read, mem read and mem write. Okay. I will just What? Someone trashed your Amiga? What? No way. Okay, so we have like different IO write, IO read pins. Wait a second, this chip is so big. Does it even fit on an M.2? On the footprint? Uh-oh. What? Johnny, thank you. Oh, it barely fits on there. Like, it barely fits on M.2. This is diagonally. It will be difficult to fit. Hype train, nice. By the way, Twitch just sent me $50 this month, so I got that going for me. Already spent for hardware. Thank you very much for all the subs. And the bits. Hello. You need the O with the cross inside. I don't know if this is even Swedish. Address. What is this? There are too many different pins. What is address? SCL SDX? What is address? What does that mean? Okay. All right, peeps. Moment of truth. Let's plug it in. Okay. I hope I don't short anything. Now we will plug in as the ground. Wait, why am I using this one? I can use the bigger. We're going to check all the pins. I will try to check D8 first to see if we actually write to the digital I/O. Typically a good sign, yeah. Unfortunately, we had small mishap, like with the design recently. Doesn't burn, but Okay, I will check what we got here. Maybe if we can make it permanent, like this stuff. Oh, by the way, here's the badge that we got for yeah, and Alex, tiny LED matrix Alex. Let me turn it on. Okay, so I got that. This is a new matrix. Here, this is a new matrix that Alex gave me. And I just bent some pins, my debugging pins, like of this one, the Rickroll. I just bent the debugging pins and put it in the power pins of the simple add-ons. So yeah, this is how I ran through the party. It wasn't a party, it was a meetup. Saturday meetup. Alright. Ground. I wanted to put some tape around ground. Here we go. There is some tape. So yeah, that was bad apple with our custom made compression method, which is amazing. And there is like several levels of compression. The MIDI file is also compressed. I ran a pattern detection on a simple pattern detection basically on the MIDI file, and then just generated patterns, and the patterns are only 5 bits or something with a lookup table. Alright, this should be ground, and this should be D8. Alright. So I just connected one probe to D8 and ground. Let's turn it on and see if it blows up. Doesn't blow up. Nice. This is Hibernate. So boring. Resuming Windows. Alright. It's there. I just run main. Yeah, nice low resistance cables. I don't see anything happening on D0. Wait, I should do roll mode. Or where is the trigger though? Trigger setup. Okay, I will turn the camera. Don't barf. Close your eyes for a second. Okay, so when I run the program, we don't see run stop, wait, auto setup. No, oh no, I pressed the wrong. I wanted acquire. No, this is way too. We don't want that. Roll mode, where's roll mode? Roll mode. Where's single? Okay, this is single. Yeah, no. Apparently Terran is right. It's only outputs. But where did you read that? Need your source of information here, my friend. Okay, let's counter that with what do we get? D whatever. This is probably the. Oh no, that's the address. Wait a second. Oh no. I didn't wire up D0 to check it. Damn. Wait, but we can. No, wait. This is. Does it trigger at some point? This is not triggered at all. Huh? Okay. Nothing. It's running in single. But where is the trigger though? I set the trigger like to 1 volt, there is nothing there. Get a live razor card. Oh yeah, that might be a good idea. Okay, I want to try something else. Live razor. Okay. EC. Then oh! Sorry, was close to the microphone. Thank you nobody for following. Tens of nanoseconds. Yeah, that should be possible. Maybe not with this scope. I'm on D8 right now. Look at this. Do I really need to write every single byte? But this is the data registers for passive parallel interface. I should be able to write it. What? You kidding? IO. Okay. Let's use mem then. I hope this, like, we don't need any offsets for the memory space. Do we? No. It's just functional. It's configuration space. The library does too much. I just want I want just to control the individual pins. Damn it. Why does it need to be so difficult? There is probably some undocumented code that I can I just need to check the library for. Let's do hacker mode. Hacker mode and check. Sorry for the bump. I bumped your microphone again. Yeah. I don't see anything happening there either. Wait, do we see? But it doesn't work. I mean, the LEDs should light up as well. They don't. What's the same pin? It's same pin. Same pin. Oh, you mean because it isn't latched? Ah, you're right. Ah, so the IO write latch isn't turning on. Yeah. So IO and memory write. Yeah, that's why it's not latching that one. Now I get it. Okay, how that interface works. Damn. Okay, so we will just write. Is it inverted then? No, it's not inverted. Yeah, that shouldn't be inverted then. Wait, it should be high all the time then. So strange. Build it, yes. But we should blink it at least. Shouldn't we blink it? Let's blink it so we have some activity going on there, like continuous activity, and let's do faster and do more. So we have some debugging time. Bias resistor. There is nothing there. Am I at the right port though? Yes. Wait, is this maybe one of those probes that doesn't have a connection? Looked like it had a connection. Wait. Check the probe before. Now that works. And probe works, okay. Horizontal, yeah, touching it. Yeah, this 100 megahertz thing doesn't, but it shouldn't be that fast. It should turn on like really slow, on and off. Oh no, it's latching. Ah, I forgot, it's latching. Damn it. Okay, let's use the other scope then. Let's pull out the gigahertz scope and see if we see a difference. There should be latching. The memory latching. I mean the latching, no, I mean the trigger right, and the pulse is short. Hey, enough. Okay, let's. That looks like some experimentation here. Signal generator. Okay. Maybe I should use. Where's this probe? Oh no. Ouch. Not sponsored. to view the glitches. Yeah. Wait, let's start with this probe though, but I think this isn't good enough. I need for these probes I need compatible headers here. Alright, here this one. Maybe maybe we can't even see that with this with the Dupont wires. Gigahertz. Yeah. All right. Pin 30. Wait. Pin. Control limit 1 nanosecond. I don't see anything. Where's the trigger? Mem. What are you talking about? There's only the D pins. Oh, this is D8 that I'm watching right now. I might need to check if this probe is working. What is this? Huh? Okay. I can try auto scale, but nah. $20 micro. Oh wait, each. Like a GABA. What is GABA? Spectrum. Yes, we can. But I can tell you, we can see something happening. Look at the code. Here. 10 microseconds. Those jumpers are crap. Yes. Should we go closer? But I can't. I really can't. I can't go. Milliseconds? Oh yeah, you're right. That's 10 milliseconds. You're right. You're right. I'm wrong. So this is not this micro stuff. Okay. Twist jumper. I mean, I'm. All right. How about this here? But then I might want, oh wait, I can use different, yeah. So I use B and C, then B and C, and then another, oh no, that's a mail, what, oh wait. Warte mal, wollte ich sagen. Hier. Ah, fuck. Radio device. I think I bought just all the different male and female. You just need to like my work area is noisy. Yes, it is. For sure. For sure. Sure. Wait, I have two female. No. I need a male connector. Yes, this is the one that I wanted. Okay. So at the end we have this length, but I can do directly to B and C as well at the end. So wait a second. We can use this one here. And oh no, and this one. Wait, this one. Arc. Okay, that's all right. Wait, I have a longer BNC cable. I can just take a long BNC cable. Should a BNC cable be all right for you? Yes, we need a new hardware revision. Unfortunately, yes. The answer is yes, we need one. On my M.2, the first PCI Express line was flipped. TX and RX Classic. Oh, look at that! I found another of those here. Okay, we can run this one. I don't need that. I need only... Yeah, but at the end I still need to screw in male and this doesn't work. This won't work, peeps. What you try to achieve. Yeah, I'm trying to see if we can actually write to the data bits, and we are doing it over, like, we are doing it with mem write d word and then sleep, and so that should be a blinky. Have a clock? No. That doesn't do, like, this doesn't help. I need to unplug the card again. Something. We should see anything there. Yeah, but I don't know which pin it is. I can see from here. What is that? Why don't I see anything? Oh, It's high. Single. I can, if I can botch it. No, no way. It's too cramped. I already ordered a new board. Because the RX and TX single. Oh wait, it's not running anymore. So how do I? Nope. Nope. Oh, yes. Okay. Hey, Sion. Okay, so I have the memory right. Where's the camera? Here. This is the mem right interface. It's very narrow. So if I do single, we can measure it is 300 nanoseconds. That's mem right, but why don't we see D? Yeah, that's 300 nanoseconds. So that's our frequency. There's not faster than that. Really? Data? Eh? If you do mem right, then you need like to it should be instantly there. Like, I mean, wait, I will do another pin here. Let's see if we get I lost my probes. Okay. Huh? Where's my signal? Oh. Come on. Wait. That's the trigger. Okay. Why isn't there anything? Oh wait, run. I'll do the trigger. Oh, it's done. Run the application again. I need to put the trigger on source 2 and then I need to trigger level. Where's the trigger? It looks like it's floating. What is this? Nah, that's not right. That looks like this probe. Maybe I need to attach it also to ground. Oh, really? Fuck. You're right. We need to pull up them. Oh no, or do we pull down? Strobes are low level. Not the strobes. Like with 10 mega ohms, maybe we have a functionality to set this actually. Let me check. Use the memRide as trigger. Yeah, but I'm blinking it. Oh wait, we can trigger. Should we make the code just faster so we be able to see anything? Like let's do without any sleep. So we can see an on-off signal right next to each other and see actually how fast can we run that on this PC though. Because that's not debuggable right now. Bidubodump. Did I compile? Yes, I compiled. Okay. Now we'll just do maximum speed. I just do the maximum. Yes, we want the maximum speed for our computer here. Oh shit! I forgot that it's that it's running a loop. Enrage. Yeah, should we? Damn it. What's the? Damn it. Yeah, we need to run. Yeah, we need to run it faster. No! I tell you, I YOLO. This is how we do things on this stream. We YOLO and then we correct it. Sorry. It's just my painful method. Yeah, I don't want to kick this. I mean, I could. I don't want to cause a blue screen when I kill the task or anything. I don't know how graceful it terminates. So at least there is some caution. Yes, welcome Dave. Yes! Yes! Yes, my friends, yes! Here we go! We see some result. We have between each write cycles three microseconds. Oh, that's a lot. Oh, that's not that great. 3 microseconds. That's 300 kilohertz. No! I want faster. Damn. That's like, I mean, that's like a sound card. Maybe we can use like a faster write mem write mode. Yeah, but we don't see anything flipping on the D pins. Okay, let me add the ground to this probe. Yeah, no, I don't see anything happening there. Yeah, but I just want to write to the 32 bits. If it's faster, why don't they give me access to all the bits? Damn it. I don't see anything happening here. Oh, actually I see something happening. You can see this is high, this is low. What do I need to do to see the actual data? Okay, look. The dip is a little bit higher, but this is like... Look, this is like 2.5 volts, it's around that, and you can see this is... It should be blinking. I don't know. You said I shouldn't. I trusted you and you betrayed me. Okay, let's pull it low, and I just need a resistor which is lit. You wouldn't recommend. It was your wording. That was your true wording. Where are my 1K resistors? Box of... I have a box of shame with all the pulled off resistors from breadboards. There should certainly be a single 10K ohms. What? No! Don't go! Bye bye, Maker. Unexpected. What? I don't have resistors. I wanted to pull down... Oh wait, here's one. Unexpected exit, yes. Here we go. I have this one. Let's check the resistance. Or else. Okay, 16 ohms is not good enough. Yeah. Did you order everything already? Damn, I just need one 10k ohm resistor. I have only SMD parts up here. I have only SMD parts here. Okay, that might help and that might help. But yeah, 1.10k ohms. I don't want like to. I mean the shitty Dupont cables have already that 800 ohms that you are talking about. Why is it so hot in here? Is this like, oh shit. Okay, I will be back in a second. I grab some. Oh wait! Here we go. Oh, Fortuna! Oh, I have 10k here. Nice. Here, 10k resistor. Yeah. Lashe Labs. Thank you for sponsoring that. 2k or up. Yeah, I have 10k. 10k should be fine. And this is... Let's do a sketchy setup. It's not so sketchy though. Wait. Hä? Nah. Let's YOLO it. Like that. Ah! Yes, they have 200 ohms series, probably protection. So, pulling it down. Okay. Moment of truth. Will it work? Will it work? I run the main again. Let's go. Boom. Nothing. Nothing, it's just low. Nope. Is this probe even working? Oh, this is sketchy. Yeah, it looks alright though with the test point. Why is it? It looks like it's only. It looks like it's only like inductively coupled or something. Okay, let me check a difference D31. No, they are all shitty. Okay, that's D something something. Nah, same shit. Scope input is AC. No, it isn't. Probe times 10 probe, yeah. D something. Direct current, not alternating current. Damn. All right. Be grounded. Okay. You know what I will do? I will connect to D0 because I don't have a single wire to D0 to see that we are not using some sort of 8-bit interface or something. It would be digital right, GND low. Yeah, that's mandatory. That's in the startup main startup. Okay, it's hibernating in a second, and then I will attach. Ouch! Aua. What did I do? What did I do? Okay, so we actually connected to mem right. That's correct. We used D8. Okay, I will do D0 now. GND, this trash can be removed. And these are the address lines, all right. So let's try again. Should I twist? No. Twist with ground. Okay. What is this? Address read, okay. Okay, let's plug it in and turn it on. I wanted to design a board with this chip, but now we are only debugging again. Talk too long about other stuff today. Oh. I plugged it. Oh no, I unplugged the card too quickly. I think it died before it was able to unhibernate. Oh, I caused the blue screen of death. Oh wait. No, it's recording for 6 minutes. Here we go. Yeah, that's not good. Oh, I should have continued. Not turn it off. Apparently it wasn't finished writing to the disk while I pulled out the PCI Express card. Yes. Hey Christian, what was going on? You missed all the fun of stuff not working. You can rewatch though. We didn't make a lot of progress. We tried a new espressive, what is it, H4 chip. P4, H4, P4, okay. I'm now tired. We really need to make this work again. Oh wow. This isn't very stable though. Look at that. Oh, but we see something happening on D0 though. D0 works. Huh? Yeah. Maybe PCI Express is busy right now. Yeah, we need to pull up, I believe, not pull down. Look at that. But why didn't we see anything happening on the D7, D8 and stuff? I mean D8, the whatever. Did I unplug all the Ds? You're kidding me. Okay. Yeah, the program terminated. Yeah, I will try again. I can't see. Wait, I can take a picture. I don't have any resistors on there. I mean, it just turns to floating, which is alright, I believe. I will just take a picture of the stupid ports. If I can. No, I can't. It's too close. No, I can't. Maybe I should take a mirror and then use a mirror. Didn't we have mirrors on our... Yeah, 0 ohm cat. I don't have a mirror. I give up. Oh, by the way, I got this here. This is what's the printed solar cells called? Perovsky solar cell. It has a laminated LED. Swarovski. Okay, I connected it to something else. Now let's check something else then. Nope. You kidding me? It's we missed something. Quantum bits, yeah. We missed something. Why does mem... Okay, that's connector XD31. Yeah, that's where we connected it. XD address. All right. Address. Oh, oh, oh. Thank you for the sub, Dave. You just shocked me with the sound. Ah, my heart stopped. My heart skipped a beat. This is how you say it in English. Lel. Oh man. Yeah, I don't know. I don't know what we missed. No, I'm using a different one. I just plugged into a random D pin. It's not like it's not writing to the upper 32 bits. I'm wondering if provide a 32-bit passive active parallel bus based upper 16 and 24. Read, write. That's the passive parallel interface. Ha. read, write. Oh, interesting. That means so what happens is with the passive parallel interface, the reads and writes are triggered externally. Read, write. Oh wow, and that's like chip select. Oh no, hey Z80, that's how it's called passive, because it only provides data when it's triggered externally. What we could cheat it by connecting yeah. So this is the passive local 32 active parallel interface. That's what we are using right now. But why does it says 32-bit or 8-bit parallel bus. PC program to read and write I/O port. No, but I don't use the I/O port. We are using the MEM interface now. Why is it still only supporting the lower bits? That's what's it says here. The active interface is either 32 or 8-bit. Yeah, we are using MEM right now, and we are using double word. So that's why I'm wondering. Okay, let me find that. Where did you find this? SPDCR. So we need to initialize that, it seems. Here you go. Yeah, you're right. Bit number 6. So F8. Is this 6 or 0? 0, 6 is 7. Okay. Alright. We can also set a faster speed. Low. We set everything to low, then it will be very fast. Yeah, this will be the fastest if we just set everything to low. Yeah, I don't care. I set it myself now. Ha! EC. No, wait. FA. No, it should be using this then. No, here. IO. Then write that. And then it should be set to... Alright. Now... let's succeed. Oh wait. Local data bus width. Okay. Oh yeah, you're right. Yeah, you're right. Moment of truth, my friends. Moment of truth. Let's swap it. Is this what I think it is? Oh, look at that. No. Oh, wait. IO byte. No. Is it IO space? Wait. Is this correct? Yes. Yes. Yes, it works. There is no resistor anymore. This works, and even like the faster timing. Look at the timing. Look at the timing. That's fast now. Oh, come on. Let me trigger first one. Here we go. And then so what is it? 40 nanoseconds. Let's run it again. 40 nanoseconds. Here we go. IO byte. It works. So switching to 32-bit. Now there is only one thing to discover. If IO also works like that. If we can write IO bits. So this is the blinking LED. Wait, I will record. Okay, so this is the blinking LED. It has no active whatever. It's floating after it was set. And this is the 40 nanoseconds that the chip uses to do it. And our, yeah, complete time is still, yeah, almost 3 microseconds. So the 3 microseconds is basically what the time that we need to run our code of the main PC. If we can use like a memory interface that writes a chunk of memory like I2S or whatever, it might be way faster. Here we go. Now, what I want to do, that we figured out how to set it to fast. DMA, yes. 20 megahertz, yes. So yeah, there is a libcall, but I want to try something else, and this is writing this here. Or maybe I will do blinky stuff. So do like that. Oh, it won't trigger on the data pin EC. I am alright with. Okay. Ooh, Zeiger to warnings, yeah. That's the warnings. EC was the data. Okay, that was the bit of register. That's IO base register. General purpose, blah blah blah. We can try address as well. We tested 200, it worked. It worked like that. Yes, it worked with 200. We tested it. You probably missed that. No, what I want to do is that's the passive parallel. That's memory data access register. Address setting. No, I'm trying to write the IO. Slave driver. Memory data access register. Data bus static input register. That's a read. Okay. This is passive. Passive will be only triggered with the external input. So I will do 0 now and check if we can access all 32 bits if we are in 32 bits mode now. This is what I wanted to test. What? And then we will try to write the address register. Yes. That will be maybe faster. But the trigger will not be correctly set now. Okay, moment of truth. Yes. I/O 32 bits. Is it? No. Is it? Yes. Yes. All right. How fast is it? Okay, I will switch now to I/O write. Yes. I/O write. Oh. All right, now this works. Writing 32 bits to I/O. What I want to do now is the address and verify that it's actually writing the I/O. But it is. We would need like different bits for both. We should maybe skip a beat. How about that? Like that. Yeah, so lower bits will be slower, lower will be slower. So we can distinguish between that. And see that we actually are doing the right thing. Oh, also the LEDs should be dimming inside of that. We need to check that. Because now also the onboard LEDs will be triggered. Use LAN, yes. Yeah, I should. But I don't have any ports free on my switch anymore. I will certainly when I start properly developing. Okay. It runs. So we would need like to zoom in. Yeah, there is high and low. Okay, stop it. Okay. This should be the high bit, is it? Yes, it is. Okay. Now, let's check for the low bit. Wait for it. Okay, this is high 32-bit. Yes! And this is the lower bits. Nice. This is what I wanted to see. 32-bit IO access works. Next on the task list is address. Let's set the address. I should. Okay, I documented the code a little bit. I will commit the current state. It's committed, you can play around. I should D word, I don't know if it's not, might be not obvious what I mean with that. I should change this to, it shows a warning. Anyways, what I want to do is now change the address, which is at here. Oh, by the way, it should be blinking or dimming or whatever. It's, I don't know if it's blinking. Yeah, it might be dimmed. It might be dimmed. I don't know. Oh. Here. Look at this. Is it dimmed? Yeah. Yeah, it should be dimmed. Maybe if I kill the application, it will change the state. No, didn't. Maybe too fast for the flip-flop. I don't know. Alright. Address setting register. F0. Let's try F0. I should have copied it. Okay. We have a 16-bit address and this is F0. Alright. Address register 0 to 15. Why? Why? What do you mean? What do you mean? What do you mean? Will it reboot or what? Why should it not work? F0. Is this page 10? No. Comparator IO base. What? You kidding me? That's alright, but selector, memory chip selection, read, write memory, membase, comparator. Why does it... Oh, there are 31 address lines. It does. Look at here. Here, that's D8 to D31. And then it does like D0 to D7. This is like... Or am I wrong? This is something that would happen if you're in 8-bit mode. It will do some sequential stuff. Toppled. Oh wait. Oh, you're right. Oh, you're right. It actually... Oh no. Yeah, but... So we need to... The lower 2 bits needs to always to be 0. No. 32 bits if we just skip the lower 2 bits. You just need to leave the lower bits alone, then it will be alright. Otherwise it will shuffle the bits around. Yeah, so that's what's happened. So if we change the address, like the lower bits, it won't. So the D8 to D31 will be always multiplexed to the right pins. But if we change the lower address bits, the 2 lower address bits, then it will shuffle one of the 4 bytes to D0 to D7. You got it right. So I need to basically... What is E? -2 is EDC. C. So we leave those bits alone. But then we have some more stuff to see here. A8 comparator IO base. Oh damn it. Internal memory. Oh, phew. This is so annoying. Internal register. What is? Okay, so as it looks right now, we can use 8 address bits. Then there is more, which will be replaced with an internal register if memory chip selection and memory read-write. Read memory. Shoot. Comparator membase. That's actually mapped on the PCI Express, which is really crazy. The only thing that we can be sure of is using the lower addresses here. So what we can do right now is that. Oh, and we need to, oh no, we need to respect what's written there. Fuck. We need to add IO base to it as well. Oh no. Comparator blah blah blah, Mr. Freeman. What? Yeah, but this is what I want to use. So I'm using the AI IO, but I want also to repurpose the address registers. The awkward thing is that there is some stuff mapping also. I mean, the lower 2 bits can be used because we transfer like 32 bits at once. Where is it? Standard IO port. I'm wondering if this is reflected, the address that we are writing to, if it's reflected to the addresses as well. But this is annoying, and we can't just write to the address. I thought, man, we can just write to the address stuff, but it's... Speaking of which, have you tried Half-Life 2 RTX? I didn't have tried Half-Life 2 at all. So I might at some point. Is it cheap on Steam right now? Or is it free? I can buy that and try it out. Alright, peeps, I think this is it. There is no way we can do it. For data looks complicated. Yeah, so there needs some swizzling to do that. I will figure it out, and I think that's good enough for today. We had some major success. Code is updated on GitHub. Check it out. Just check out bitluni on GitHub, and there should be the last repository. Use library. Not knowing is the part of fun. Yeah, but the library wants like to use some sort of memory interface there. I mean, we could light up LEDs as memory just by basically using the address lines, 8 address lines, or like let's say 6 address lines as segments of the display, and then the data lines as the individual LEDs in the segment. And then we can just write chunks of memory per each frame is just a chunk of memory. I/O control type function for everything. But Terran, where do you check? Where do you know that from? Did you check the Linux implementation or what? Or did you disassemble the library? Oh, the Linux code. Okay, yeah. I will check that out. So, peeps, it was fun today. I don't have the original Sonic. Alright, it was fun, it worked. We are able to write 32 bits. Next week, this Friday, I can't stream. I'll be visiting a friend tomorrow, and then quality time. And next week, I hope the PCBs are there and we can do actual debugging. If not, we will do a new PCB with this chip here. Kinda able to write 32 bits, yeah. Alright, bye bye everyone. It was a blast. Good night and have a good sleep.